In this problem, we're looking at a manufacturing company. They have two machines building the same product. The first machine produces a flawed product 12% of the time. I'm just going to underline that. That'll be important, but I'm not quite sure how yet. The second machine will produce a flawed product 5% of the time. And the probability that both of the machines will produce a flawed product is 6%. Now this word both means that it's going to be happening at the same time, so it's not just one or the other, but it's both of them. So this is an and, okay, or an intersection. Let me use an arrow. I don't want to use the word or, that would be confusing. Okay, so that's what that's really telling me to do. So the first thing we're asked to do is determine whether or not these events are independent. So remember, our independent rule is the probability of A times the probability of B equals the probability, of A and B. All of these probabilities have been given to us. We don't have to do any calculations. We just have to figure out which is which. So I'm going to say that event A is the first machine, and I'm just going to jot that down off to the side here so I don't have to try and label it in the paragraph here. And we're told that the probability of that happening was 12%. Now, if you're going to do multiplication, you need to convert that. So if it looks like 12% as a decimal, it's 1200ths. I'm going to call event B, kind of by default, since A is the first machine, then B is the second machine. And again, I'm just going to take the information right out of the problem. We're told that flaw happens 5% of the time. 5% as a decimal is 0.05. And it's going to equal the probability of A and B happening together. And we're told that that probability is 6%. 6% looks like 0.06. And so as we have with the other probability questions, we're going to do the math and we're going to compare. So if we were to do 12% times 5%, 12 times 5 is 60, but my decimal place, you see this weird funky symbol here, that's scientific notation. That's telling me that I need to have 3 decimal places. So I would take this 6 and go 1, 2, 3 places to the left. Let me show you what that looks like on the paper. If it's 6 and it has a -3, we would start here and go 1, 2, 3 places to the left like that. So that's actually 6 thousandths. Whereas over here, when we had the probability of the overlap was not 6 thousandths, but 6 hundredths. So although they look similar, they are in fact not the same. And so because they are not the same, they are not independent. The second part of this question is asking us the probability of machine 1 or machine 2. Again, we don't have to do any calculations, we just need to plug into the right rule. Since it's an or, we will do the probability of A plus the probability of B minus the probability of A and B. Now I've already defined A and B over here, so I won't define those again. My answer, the probability of A or B, is equal to 12 hundredths plus 5 hundredths minus 6 hundredths. And so when I calculate that one all the way through, 12 plus 5 is 17. 17 minus 6 is 11. And so the probability of A or B, that is machine 1 or machine 2, is 0.11 or 11 hundredths, also equal to 11% of the time one or the other machine will have a flaw.